So for task one, you're being asked to solve for x. You want to solve inequalities the same way that you would solve equations. So you almost want to pretend like those inequality signs, those greater than or less than or greater than or equal to or less than or equal to signs are like equal signs, and just do the same thing for both sides of your equation that or your inequality that you normally would do for an equation. So I'm going to do A as an example, and then I'll give you some hints for the B, C, and D. So for A, again, we're going to just pretend we are just given our regular inequality. We're going to treat it like we would an equation. Right, we normally would try to keep our equation balanced and do anything we do to one side of the equation, we would have to do to the other. Same thing with inequalities. So in order to solve for x for this inequality, we would have to divide both sides by 5. That way you get a giant 1 here. 5 divided by 5 is 1. So on the left-hand side, we have 1x, which is just x. And on, not equal, it would be still less than. And on the right-hand side, we have 10 divided by 5, which is 2. So the solution to our first inequality is x is less than 2. So x is less than 2. My hints for the next ones are for B, you are going to want to start by adding 2 to both sides of your inequality. For C, my hint to you would be to combine the like terms on the right-hand side of your inequality. And for D, my hint to you would be to distribute on the left-hand side of your inequality and combine like terms on the right-hand side of your inequality. So if you have any questions about B, C, or D, or would like me to check your work, just raise your hand and I will come to you. All right, for task 2, part 1, you are solving each inequality, then checking your answer using a value that makes your inequality true. So again, I will start with A. So for A, we have negative 2x is less than 4. And again, we're going to solve this like we would any other inequality. However, if you remember from middle school, when you multiply or divide by a negative with inequalities, you have to flip your inequality symbol. So in this case, in order to solve for x, I would have to divide both sides of my equation by negative 2. That would give me that giant 1, so that way I can get a 1x on the left-hand side. But because I divided by a negative, I would have x on the left-hand side, and I would flip from a less than sign to a greater than sign. And then on the right-hand side, we have 4 divided by negative 2, which is negative 2. No, yeah. 4 divided by negative 2 is negative 2. All right. So we solved our inequality. So our solution for A is going to be x is greater than negative 2. And we can check our answer by plugging in a value that is greater than negative 2, plugging it into our original equation and seeing if it still makes a true statement. So we know that 0 is greater than negative 2, right? This is true. So let's plug 0 into our original inequality and see if it's true. So we have negative 2 times 0 is less than 4. Well, negative 2 times 0 is 0. 0 is less than 4 is true. Okay, so we plugged in 0 and we saw that A is true for everything that's greater than negative 2. Okay, so you would do B the same way. So my hint for B would be that I would start by subtracting, or maybe, no, I would start by adding 4 to both sides, and then you would have to subtract your x terms from both sides in order to solve for x. For C, you would have to distribute on the left-hand side and then do your steps for solving two-step equations like adding or subtracting your constant from both sides and then dividing by your coefficient. For part 2, the directions say for each statement, use a number line to show which values satisfy the inequality, then express the statement symbolically with an inequality. So A, the elevator can lift up to 1,200 pounds. Let X represent the weight being lifted by the elevator. So X can lift up to 1,200 pounds. So if we're going to compare X, which is the weight in the elevator, and 1,200 pounds, right? X would have to be less than or equal to 1,200 pounds. When we're talking about up to 1,200 pounds, we're talking about if we're starting at 0 and we're going all the way up to, let's say, 2,000. And in here we have a value of 1,200 pounds, right? The elevator can be at 0. It could be at 1, 2, 3, 100, 200, 300, 400, 500, 600. It could be at 1,000. It could be at 1,200, but it can't be at anything more than that. It can't be at 1,300 pounds. So it's everything that is 1,200 pounds or less. So on our number line, again, if we're going from 0 to, let's say, 2,000, or let's count it out. Let's count it out by hundreds. So let's do 0. Let's call this 100, 200, 300, 400, 500, 600. And I'll write it out every 500. 500, 600, 700, 800, 900. This is 1,000. And then this is 1,200 is be right here. 13, 14, 15, 16, 17, 18, 19, 20. Okay, so yeah, it goes up to 2,000 if we count by hundreds. So since this at 1,200, including 1,200, it could have up to 1,200. So including 1,200, so we got to shade in our dot, and everything less than that. So we have to shade everything to the left and draw our arrow. So everything that's less than or equal to 1,200 could be weights that the elevator could hold, right? And make sure that your dot is circled in because it can include 1,200 pounds. And that inequality would look like, again, X has to be less than or equal to 1,200. So similar to that, part B says there's a minimum of 3 years of experience required, I guess, for some job. Let X represent the years a candidate has. So a minimum of 3 years. So in order to work at a job, you have to have a minimum of 3 years experience. So ask yourself, can you have less than that? Can you have more than that? Can you have that amount, right? Which will determine if your circle is shaded in or not. And then for the last part, we are pretty much going to solve these inequalities on the left and match them up with their graphs on the right. I will leave this up to you. For the last inequality on the left, you're going to have to distribute. Trying to think if there's anything else that you might know to do. I will say that one hint is, again, looking at whether your circle is shaded or not, and remembering that an open circle is for less than or greater than, and if you have a closed circle, then that is for less than or equal to or greater than or equal to, right? The closed circle just means that that number is included, so we have to include the and equal to part, okay? Open circle just means everything less than or everything greater than, so it would help to look at the inequality symbols and match them up with the open circle or closed circle, and it would also help to solve the inequalities and make sure that those values are true. So you could plug in possible values. So for example, this first graph, you could plug in, let's say, well, 0 is a solution for all of these. You could plug in a solution that's only possible with this first graph. So let's say, well, 2 is a possible solution for the first graph, but it's also a possible solution for the third graph. So if you plugged in 2 to any of your equation or inequalities on the left, which ones would it work for? And then you could plug in like other numbers to the left or right, depending on what part is shaded.